Today, we're going to make our particles rotate. Let's go. Alright, so this is the 8th video in our series on making a particle system using the Unreal Material Editor or Unity's shader graph. If you haven't seen the other videos yet, I'll link the playlist down in the description so you can catch up. So far, we've added enough features to create the effects that you see here. Last week, we added wind and gravity, and you can see examples of that here. So over here on the left, we have a particle effect that's becoming a waterfall, and it's going to look more and more like a waterfall as we progress further into the series. Next, we have this smoke particle effect. You can see that the wind that we added last week is carrying the particles away. Here we have a fountain, and then over here on the right we have this drifting mist. So today we're going to make our particles rotate, and right now they're all lined up perfectly with the camera, but we want to add some controls so that we can give them some rotation. So let's switch over and take a look at the shader that we're creating. So this is the shader that we've created so far in the series. We've given our particles a lifetime, direction and speed, wind and gravity. We've created random values so that we can make each particle behave differently. And we've given them position and offset. Up here we've got our controls that make our particles turn and face the camera. So today we're going to add rotation. Here you can see kind of a preview of what our particles are doing. Before we add rotation, I want to make a couple of changes so that the rotations will be more obvious. I want to kind of slow our particles down, make them move a little bit less. So we're just going to change some of these default values. I'm going to make our velocity start and our velocity end values 0 so that our particles don't move. I'm going to set our gravity to 0 as well so that our particles don't get pulled down. And then for our scale, I'm going to set our particle start size and our particle end size both to 2. And what this is going to do is make our particles just kind of stay in one spot. And it'll be easier to see the rotations that they're doing because they're not moving all around. All right, so now that we've made that change, we want to make our particles rotate. Right now, they're just all lined up perfectly square with the camera. So in order to do our rotation, we want to add a custom rotator node here. And this node is designed to allow us to do the rotation. So if I just go ahead and plug in our custom rotator node to our billboard node here, you'll see that, all of a sudden all our particles are gone. And that's because we haven't given default values to our custom rotator yet. This is asking for our UV coordinates. Just like our billboard node wants UVs, our custom rotator node needs the default set of UV coordinates that our particles have. So I'm just going to add a texture coordinate node here, and we'll plug that into our UVs. Now it wants, now our particles are back. Cool, that's great. Now it wants to know where the center of the particles are, and that's pretty easy. We can just hold down the 2 key and click, and this is going to give us a vector 2 value, and the center is 0.5, 0.5, so right in the middle of the UV coordinates. So we can just plug that value in as our rotation center. And now it wants a rotation angle. It's a value between 0 and 1. And so if we're thinking about this in degrees, 0 is going to be 0 rotation, and 360 degrees is going to be rotated all the way around and back to where we started. And so that's a value of 1 on this scale. So instead of using degrees, we're using a 0 to 1 range. So if I hold down 1 and add a parameter here, now if I give it a value of 1, our particles are going to be rotated 100% all the way around, and you can't tell that they've been rotated at all. But if I give it a value of something like 0.1, now you can see all of our particles are rotated just a little bit. They're all off axis. So this is the rotation that we're looking for. It's a little bit more intuitive if we can think of the rotations in terms of degrees, though. And so I want to treat this value here as degrees and then convert it into the 0 to 1 range that our custom rotator value or our custom rotator node wants. And so in order to be able to convert from degrees to the 0 to 1 range, what I can do is use the reciprocal of 360. And how do I do that? Well, I'm going to divide 1 by 360. And this is going to give me the reciprocal of 360. And then I can just multiply that by our incoming value. So I'm going to take this and multiply it by our reciprocal that we've created here. And now what I've done is allowed myself to input this value in terms of degrees. So I could type 45. Now they're all at a 45 degree angle. I could type 50, and now they're all at a steeper angle. So I'm now able to control this value in degrees instead of that unintuitive 0 to 1 range. Okay, so this is the basics of our rotation. I've enabled us to put in one static value and rotate all of the particles up to that amount. Actually, you know what we should do right now? We should expose this value as our parameter. So let's go ahead and do that. And so I'm just going to right click here and pick convert to parameter. And we're just going to call this rotation. So this is, if we want to give all of our particles one static rotation value, we can use this parameter to do that. I'm just going to set it to 0 for now. The default value to 0, that is. And the next thing that we're going to do is add some animated rotation. And we're going to add that to our static rotation value. Let's grab all our nodes and just move them up so that we can isolate them up here just a little bit. Okay, the next thing that we need is a time node. And then we're going to multiply time by a parameter that controls the speed. So I'm just going to add a constant value and then right click and pick convert to parameter. And we're going to call this one rotation speed. And this value we can use to control how fast the particles are rotating. So by introducing time here and speed, we're going to be able to animate our particle rotation. Now this is our static rotation value here. And if we just add our animated rotation value to it, we're going to be able to animate the rotation of the particles. So right now our rotation speed is 0 and our rotation is 0. But if we make our rotation speed 1, oh, that is very slow because it's rotating at 1 degree per second. Let's set that to something like 30. Okay, now you can see the particles are rotating. You know what? They're blinking in and out kind of quickly. And so let's go ahead and change our lifetime value. If we set our particle speed to something a little bit slower, yeah, 0.05. Now you can see our particles are rotating and they're not popping in and out quite as frequently. So it's a little bit easier to see what's happening. All right, so we've added time multiplied by our rotation speed to our initial rotation value. And now we can either make particles that are rotating statically or particles that are rotating dynamically. If we want them to all rotate the same amount and not animate, we can set our rotation speed to 0, and then we can set our rotation value to however we want all the particles to rotate. But if we want them to animate, again, we can set our rotation speed there. And this is a value that's in degrees per second. And now we can see all our particles rotating. Okay, but one issue that we have here is all of the particles are rotating at the same speed and the exact same amount. And in order to make this look a little bit more chaotic and a little bit more natural, we want to introduce a little bit of randomness to the particles' rotation. And the way that we can do that is previously, on a previous episode, we did this operation down here where we added this vector noise. And what this does is it creates these random values. So you can see the random values expressed as color here, where each individual particle has its own color. And we took those colors and multiplied them by 2 and subtracted 1 so that they're all in the -1 to 1 range. And what this is doing is each individual particle has its own set of 3 random values. And we can use these values to give each particle its own unique behavior, including rotation. So I'm going to go ahead and take this random value that we have here and drag it up here so we can use some randomness in our rotation calculations. And I'm going to add a split components node because those random values it's a vector 3. And so now we have red, green, and blue, these 3 different random values that we can use. I'm going to go ahead and take the green channel, and right now it's in a range of -1 to 1. And I'm going to multiply this value by 180, which will expand that range. So now my random value is from -180 to 180. So each particle gets some random value somewhere between -180 and 180. And if I take that value and multiply it by the rotation that I've calculated so far, we'll give each of the particles a random rotation offset somewhere between -180 and 180. And you can see here my particles are going crazy fast, and that's because instead of adding my random value, I multiplied it, and so the rotation speed is really, really high. I need to add an add node here instead of a multiply to get the correct behavior. All right, there we go. Now you can see each individual particle has its own random offset. They're no longer moving like all in lockstep as they were before. Okay, so we've introduced this randomality to it. Okay, what if instead of all of the particles having random offsets, I don't want them to have random offsets? Well, in order to do that, I need to add a switch. So I'm going to type switch and pick static switch. And what I've done here with this calculation is give myself a random offset. So I'm going to add that into the true branch of the switch. And if I don't want the random offset, I'm going to add the part of the rotation that doesn't have it added in yet. So here we've added in our random rotation. Here we don't yet have it. And so we're going to switch between either randomly rotated or not randomly rotated based on another parameter. So I'm going to add a static bool parameter. And let's set this one to true by default. And we'll give this one the name of rotation random offset. And we'll plug that into our value. So in the material instance that we create for our particle systems, we'll either be able to turn on this random offset that we've added, or turn it off if we want all the particles to rotate uniformly. Okay, so right now with the rotate random offset set to on, you can see that each particle has its own individual rotation offset. And if I turn this off, now they all rotate uniformly together, so they all have the same rotation values. Okay, that's pretty cool. The next thing that we want to do is change the particle's direction, because right now you can see all of our particles are rotating in the clockwise direction. And we want to be able to allow for people to rotate some particles clockwise and some counterclockwise. So in order to do that, we're going to use our random values that we brought in here with our split component. This time we're going to use the red channel, and I'm going to drag that one out, and we're going to add a sine node. Now what this node does is it returns -1 if the value is negative, and it returns +1 if the value is positive. So each particle is going to be either -1 or 1, depending on if our random value is positive or negative. And so we can take the result of our rotation calculations here and multiply it by that sign to either flip it negative or keep it positive, which will rotate the particles in the opposite direction. So here is my -1 or 1 value. I'm multiplying it by my rotation values here. And now I'll plug this in. And what you'll see is that now we have some particles rotating clockwise and other particles rotating counterclockwise. All right, this is pretty cool. We're actually getting something that is like really flexible and really controllable. And just like we did for our random offset here, we're going to add another switch so that we can turn this feature on or off. So I'm going to add in a static switch. I'm going to plug this value into true. And before we add in the random direction here, I'm going to plug that value into false. Now we need to create another Boolean parameter, static bool parameter. And we're going to name this one random rotation direction. And we'll set this one to true as well. So if we plug this in, now with this true, each of our particles is rotating in a random direction. But if we turn it off, now they're all rotating clockwise. All right, very nice. So we've got all the rotation parameters that we need. We've got our static rotation value, we've got our rotation speed, we've got the ability to control if all the particles are rotating uniformly or if they all have a random offset, and we have the ability to control if they're rotating in random directions or all rotating in the same direction. Okay, this is great. Let's go ahead and do a little bit of graph organization here, just to kind of clean things up. And then we're going to switch over to the particle systems in our scene and take a look at how we can use these parameters to make those particle systems more realistic looking. All right, here we are in our scene, and I've got a cool little demo set up for us so that we can take a look at what the rotation parameters are doing that we just added. So here on the left, I've got our fountain particles. And here I have the material instance parameters that control the fountain. And here you can see we've got this new section added called rotation. And we have our rotation value, our rotation random offset, rotation speed, and random rotation direction. So for each of these particle effects, we're going to add in the rotation values and see how we can improve the look of the effect. So right now in our fountain, all of our particles are uniformly lined up with the camera, but we can take this and add in our parameters. So rotation we're going to leave at 0, that's our static rotation, but we want our rotation speed to move. So I'm going to give this a value of -30, and that's in degrees per second. And now you can see we've got a little bit of interesting rotation happening with our particles, but they're all rotating the same direction, and that's not what we want. So we're going to turn on random rotation direction so that some of them will rotate clockwise and some counterclockwise. And then we're going to also turn on random rotation offset so that each of them has a unique starting rotation that we're giving them. And now you can see for our fountain, we have a much more dynamic looking effect. We have our particles kind of all randomly rotating instead of just being static and all lined up with the camera. So we've got a particle effect that is a lot more interesting to look at. All right, let's do the same thing for our chimney smoke. And actually, looking at my notes here, our chimney smoke is actually just going to stay exactly as it is. The flipbook texture that we're going to apply to these particles eventually has a directionality to it, and it's important that all of the particles stay lined up. And so we're actually just going to leave the chimney smoke as it is with rotation turned off. Actually, I'm going to turn this on, and just so these particles don't get overridden if we happen to change the defaults out from under them. All right, now let's take a look at our fountain. We'll kind of expand this out and come over here and look at our fountain. The fountain is going to be similar to the waterfall. So let's turn on our random rotation offset, and we'll set our rotation speed to -30, and we'll also turn on our randomized rotation direction. So now you can see our fountain particles are significantly more dynamic looking because each particle has its own rotation and random offset values. So we get something that's significantly more chaotic and natural looking. All right, let's do something similar for our mist here. We've got this really calm floating mist particle effect going on right here. So for our mist rotation values, we're going to set it to 0. We're going to set our rotation randomized offset to true. We're going to set our rotation speed to just something very low. We want the mist particles to just kind of drift, and you can see they're doing that now. And we're also going to turn on randomized rotation direction. So now you can see that our mist particles are just, very calmly drifting, very subtly rotating. And if we zoom back out here, if you can keep in mind what we had here before with all the particles like statically lined up with the camera, now we have something significantly more interesting where we've really randomized the rotation and given a lot more dynamism to our particles. All right, so that was our objective for today. Right now, all our particles have these rainbow colors applied to them, and they're all just square shaped. But next week, we're going to be adding flipbook textures to the particles so that they actually start looking like smoke and mist and foamy water instead of just these square particle sprites. So that's going to be a great one. Hope you tune in for that one next week. In the meantime, let's switch over to Unity, and I'll show you how to add the rotation calculations in that engine as well. All right, here we are in Unity, and just like we had in Unreal, we have our 4 different particle effects that we're working on here. Over here, we've got our waterfall, and we've got our chimney smoke here, and our fountain, and our drifting mist. And all our particles are completely lined up with the camera and kind of static right now. But what we're going to do is add rotation to these particles to make them feel more natural. So let's jump into our particle system. So here's the particle system that we've been building in Unity. We added particle lifetime, billboards, direction, and speed. Last week we worked on adding wind and gravity to our particle effects. We start out with by generating random values for each particle, and then we offset the particle's position here. But today we're going to be adding rotation. And we're going to start right here with our billboard node. So in order to do rotation, we need to add the rotate about axis node here. And we can just take this and plug it directly into our billboard. And actually, you know what? Let's open up our preview window. So I'm going to grab our preview and just put it right over here. And right now our preview window is empty, and that's because we're not passing in good default values for our rotate about axis node. So I'm just going to disconnect that for now. Yeah, so now you can see we're getting some good results here in our preview. Now, in order to see things a little bit better, we need to change some of our default values. And so I'm just going to come over here to our blackboard, and we're going to make these, what we want to do is make our particle effects just kind of more static for now, so that while we're previewing what we're doing with rotation, we can actually see what's happening. So we're going to set our particle start size and our particle end size to 2. And we're going to set our particle speed to something just really slow. And we're also going to set our gravity to 0. And then we'll set our start and end velocity also to 0. Oh, looks like we need to spread these out a little bit. So we'll make our emitter dimensions a little bit larger. Maybe a little bit smaller. Okay, so now we've got a nice mass of particles that are kind of staying still for us. So when we make them rotate, we'll be able to see what's happening a little bit better. All right, so we've got our rotate about axis node, and you can see that it's taking an input value. For the input, I'm just going to give it the position. And we need to make sure that this position is in object space, because in Unity, we're doing all of our particle calculations in object space. All right, and for the axis, we're going to set this to 0, 0, 1, because we're rotating at around the camera vector, basically the vector that's going from the camera to the object. And then the rotation value is what we're going to be calculating. So now I think when I plug this in here, now that we've got these default values set, our particles actually draw correctly. And so if we change this rotation value, you know what, I'm going to add a slider here just so that you can see what's happening. We'll plug this in. And now you can see as I slide this, our particles are rotating. But this rotation value is in radians. And I actually want to work in degrees. So I'm just going to set this to degrees here. And now I can set my slider to go from 0 to 360. And you can see as I slide this, my particles are going all the way around. They're starting at 0, going all the way around 360 degrees. And so in order to control the rotation of the particle effects, I just need to control the value that I'm inputting here. So I think the first thing that I'm going to do over here on my blackboard, I think I'll just go ahead and add all of my parameters in one go. The first parameter that I want is just a rotation parameter. And this one is going to control the static amount of rotation that I want my particles to have. I'm going to come over here and I set the mode to a slider, the default value to 0, and then I'm going to set it to -180 to 180. And that's going to allow me to give all my particles just a flat, static, non-animating rotation value. All right, the next parameter that I'm going to create is a Boolean. And we're going to call this one rotation random offset. And we're going to default this to true. And this value is going to control, whether or not all the particles have a random offset value. If they're all rotating uniformly, or if they each have like a different rotation value. The next parameter is our rotation speed. This is going to control how fast they rotate. We're going to give this a default value of 80. That's 80 degrees per second. And next we're going to add another Boolean. And this one is going to be our randomize rotation direction. And this property is going to allow us to rotate some particles clockwise and others counterclockwise. And we're going to set the default value to true. All right, so now we need to use these. The rotation is the easiest one to use. We can just bring it in and plug it in. And there we've got our rotation set up. The next thing that we need to do is control our rotation speed. So we'll bring that in and we're going to multiply this by time so that we can actually control how fast the particles are animating. So we'll bring in our time, multiply it by our rotation speed, and then this is the initial static rotation that we're giving our particles, and we're going to add that value together with the animated rotation. And now when I plug this in, you'll see that our particles start animating. Pretty cool. Oh, you know what? There's one other thing that I want to do in the blackboard here, and that is I want to select these parameters, like multi-select here, and create a category. So I'm just going to put all of our rotation parameters in a category, and we'll double click here and just call these rotation, just to kind of keep the order of parameters nice. I'm going to put our rotation parameters right up here under movement. There we go. So now we have our movement parameters and our rotation parameters. I'm just going to keep our parameters nice and organized in our blackboard. Okay, so we have our rotation value, we have our rotation speed, and right now we have all of our particles rotating, but they're rotating all at exactly the same speed and exactly the same amount. And we want to introduce some randomness in here so things look a little bit more natural. So what we need to do is come down here to where we've calculated our random values. You can see our random values kind of illustrated here because each of the particles has a different random color. And that color is coming from this function that we created a couple of videos ago. This is our #33 function. So this gives us the color, but then we multiply it by 2 and subtract 1, which expands our random range from 0 to 1 to -1 to 1. And this is the random value that we want. So I'm going to grab this random value and bring it up here. And we're going to add a split node. Because the value that we've calculated down here, you can see because these wires are yellow, that means they're carrying vector 3 values, or a set of 3 float values. And we'll bring that up here. And now we've got R, G, and B, red, green, and blue. And these are the random values that we can use. Now, what I'm going to do is I'm going to use the value from our green channel here and multiply it by 180. And the reason that I'm multiplying it by 180 is because right now it's in a range of -1 to 1. And by expanding it or multiplying it by 180, now it's in a range of -180 to +180. And so what I can do with this value is go ahead and add it to the rotation values that we've already created. So now I have randomly offset particles, and I'm adding this additional value to our rotation amount. So what you're going to see when I plug this in is that now each of our particles starts off with a random value, so they're not all uniform. Each one has a different rotation value applied, and it adds this really nice looking natural chaos to things. Okay, so there may be some cases where we want that, and there may be other cases where we don't want that. And so what I'm going to do now is add in a branch node, and this is the same as the static switch node in Unreal. And we're going to bring in our rotation random offset parameter here, this Boolean, and plug that into our branch. So what this is going to do for us is, if this value is false, we want to just use the plain Jane rotation values here. But if it's true, we want to use the rotation values with the random offset applied. So now we can use this rotation random offset parameter to control whether or not we're going to use this randomness in our rotation. All right, you may have also noticed that all of our particles are rotating in the same direction. And if we want some of them to rotate clockwise and some to rotate counterclockwise, we can also do that. We'll use the red channel of our random values here. And I'll drag this out. And I'm going to add a sine node, not S-I-N-E, but S-I-G-N. And what this node does is it takes this random value, and if it's negative, it gives us a value of -1. But if it's positive, it gives us a value of 1. And so what that allows us to do is, if I multiply this value that's either -1 or 1 by our rotation value, I've now flipped our rotation on some of the parameters, the ones that get a -1 from this sine node. So now as I plug this into our rotator, now you can see some of our particles are rotating in one direction and some are rotating in the other direction. All right, so that's fantastic. And now, just like we did with our rotation random offset using a branch here, I'm going to grab our randomized rotation direction parameter, and we're going to add another branch node, and we're going to branch based on this parameter. So if we do want randomized rotation direction, I'm going to plug that into the true pin here. And if we don't, I'm going to plug in what's coming out of this branch into the false pin, so that with this parameter we can control whether or not we're randomizing which direction the particles are rotating. So now I'm going to just plug this into our rotation. And now we can use this parameter. So if I set randomized rotation direction to true, this is what we get. And if I set it to false, now all our particles are rotating in the same direction. All right, so we're all set. We have all of our rotation calculations set up. We just need to clean up our graph a little bit here. Make things a little bit more organized. And I'm also going to select all of these and pick group selection. And we're going to call this group rotation to keep things nice and neat. All right, so let's go ahead and save our results. And we'll switch over to our scene and take a look at what we can do with these new parameters. Okay, here we are in our scene, and you can see that just like I had it set up in Unreal, I've opened up the materials for each of our particle effects. And here are our rotation parameters. So here is the fountain effect here, over here on the left. I'm just going to zoom in here. And you can see we've added rotation. And we've got this randomized rotation going. And we have our rotation speed set at -30. I'm just going to set this to 0. So this is what our effect looked like before. And if we add -30 as rotation speed, rotation random offset, and randomized rotation, now we end up with a waterfall effect that's looking a lot more organic, with these particles looking very chaotic and random instead of all uniformly lined up like we had before. All right, next let's take a look at our smoke. So with our smoke effect, what we're doing is we've got our rotation actually set to 0, and that's because next week we're going to be adding texture to our particles and using an animated texture. And the animated texture that we're going to apply to the smoke happens to be something that needs to stay oriented kind of in the same direction. And so we're keeping all the particles the same for that reason. So you want to tune in next week to see us start adding texture to these, so we've got something a little bit more interesting than just these like colored squares for our particle effects. All right, let's take a look at our fountain. We can turn off our rotation here, and you can see our fountain's looking significantly more like plain and normal. But if we turn on our randomized values and give ourselves that -30 for rotation speed, you can see we end up with something that's a lot more dynamic. All right, and then for our mist, you can see that our mist is also looking more dynamic with our random rotation. We've got our randomized values turned on here, and we've got our rotation speed set to 7, which means the mist is just kind of slowly drifting. This is 7 degrees per second. So without our randomized rotation direction here, you can see all of the particles are rotating in the same direction. But when we turn that on, we introduce this chaos and it looks more interesting. And we can also turn on rotation random offset, which then makes each one have its own initial rotation applied. So we end up with something that's a lot more organic. All right, so that is how we add rotation parameters to our particle systems. I hope you can see that these effects have given a lot more life to the effects that we started out with, and that they're just a lot more interesting and will end up looking a lot more like the phenomenon that we're trying to imitate with the particle effects. All right, like I said, next week we're going to be adding the textures to the particle systems. This whole time we've been using these like randomized colored squares, and finally we're going to be adding flipbook animation along with the textures, so that we end up with something that looks a lot more like the effects that we're trying to imitate. All right, come back next week for that, and in the meantime, have a great week, everybody.